You're listening to the Common Descent Podcast.
Hello, David.
Hello, Will.
And hello, listeners. Welcome to episode 90 of the Common Descent Podcast.
9-0.
9-0.
What's on the agenda today?
We are going to talk about living fossils.
Ooh, a controversial episode.
Yeah, very much so. This is a term that I would hazard, if I had a gambling problem, I'd hazard a bet that almost all of our listeners have heard this term.
It's a pretty common term.
Like, this is widely used. It gets thrown around a lot.
News, movies, games, all over the place.
It's popular. And this is a term that is typically used to refer to creatures or, any form of life. There are plants
fungi,
and stuff that fall into this, but usually it gets thrown at animals because of features they have that either make them seem like they should fit within the fossil record, or make them look like fossil members of their lineage.
Right. This came right out of the Jurassic period.
It just looks like it should be walking with the dinosaurs. Stuff like that. And so it happens with every group of life, but it happens more commonly with the ones that people can readily go, yep, that looks like the thing I saw in the movie or museum.
And it's a term that scientists have a complicated relationship with.
Absolutely. So we're going to discuss what it is. What is the term? What does it mean? How is it used? What is this complicated relationship? Why is it debated? We're going to kind of start with that because that is, if you were to look up just the term, that's going to be a bulk of the discussion on the term.
Mm-hmm.
And then we'll go through how did the term come to be? What are some examples, and what are some of the arguments for and against those examples?
Right. And we should stress that a lot of paleontologists do not like this term.
Yeah, this is...
But not all of them. There are people out there who like the term, even professional paleontologists who actually do like the term.
Yeah, this is one of those where if you were to go up to a random scientist, if you go next time you go to a museum and just ask their opinion, you could get either answer.
But it might be a passionate answer.
Yes, exactly, with differing amounts of passion.
Yep.
So we'll go through and discuss it and explore it. And part of the reason we're going to discuss this topic is because it was requested.
By who?
By two of our patrons.
Oh, goody.
Dylan and Catherine.
Thanks, folks.
This was actually one of our earliest requests. And I think our first in-person request.
I think so. I think Dylan's request was on the list. It was one of the very first on the list from way, way, way back in the day.
Before we get started, let's get our announcements out of the way, because we always have a little bit of announcements. And to start it off, mentioning patrons, we do have a Patreon. And the Patreon allows us to keep above water and keep the podcast running and do cool stuff.
And allows us to reward our patrons and supporters with goodies and behind-the-scenes stuff and extra things.
Exactly. If you sign up at a certain level, we shout your name out here on the podcast. And our new patron for this episode is Kevin.
Thanks, Kevin.
So welcome aboard, Kevin. Thank you so much. The only other announcements we have are really some reminders. Once again, we have a store with merch you can buy if you want stuff with our stuff on it.
Yeah, link in the description for the episode.
Absolutely. There's the art from Rob on there, so if you haven't got a chance to check that out, go check it out.
Get yourself awesome. A shirt or a mug or something, because it's cool new stuff.
And last episode, we had our announcements that focused on the current state of the Black Lives Matter movement and the protests going on with that, and we put some links in the description with information and sources and resources for you to look at if you want and to educate yourself. And we are going to relink that this time so that it is once again available for you if you are hoping to find more information on this topic.
Yes, this is a situation that's still ongoing, and we continue to learn ourselves and support anti-racist movements around our country, around the world. So links back in the description of the episode if you want to check it out. And you can go to our social media for our official statement and information and discussion.
Yes, indeed. And that brings us to the end of the announcements, which lets us start the news.
The news?
Every episode, we like to discuss a little bit of science news, paleontology, evolution, and other cool findings. Because we like to stay up to date. We like you all to stay up to date. So, to start us off, I'm going to turn it over to my colleague David.
Horned gophers.
I'm ready. That you got me right there.
This is research. That's it. Horned gophers. This is research by Jonathan Khalid and Josh Samuels.
Hey!
Our friend Josh, who works here at ETSU in the Gray Fossil site.
I know him.
Yeah, no, he's a cool guy, which is why I know about this paper. There's research published in the Journal of Systematic Paleontology, and as of this recording, last I checked, there is not the official press release out through ETSU, but there should be soon, and when it is, we will link that as the popular article in our blog post. Officially, it is released through ETSU. Press releases don't get a byline, typically, but I wrote it, so it's good. There is an extinct group of rodents called mylagolids. They are completely extinct. They lived during the Miocene and thereabouts. Their closest living relatives are a group of rodents called suellals, also aka mountain beavers.
Oh.
Not real beavers, not like true beavers,
Yeah.
but this weird basal strange rodent, Western North America. But what makes the mylagolids unique and especially interesting for this discussion is that of the 30 plus species of them that are known, 5 had horns on their nose, like rhino-style horns.
Nice.
Except that, as we'll discuss in a bit, this one has 2, like paired horns.
Compensation.
Well, it's a little animal. These existed between roughly 16 and 5 million years ago, and this new paper describes the 6th horned species.
Cool.
And not only is it a cool new species, rodent with horns, but fills in some of the evolutionary story of how and why these rodents had horns.
I'm ready to learn.
This study describes a new fossil from northwestern Nebraska, which is just the front of the face.
Enough to confirm horn on the nose.
Enough to see the 2 side-by-side horns on the nose.
You got the right part.
This is an animal that would have been roughly groundhog size, so like a groundhog. The authors say that they estimate its weight to be about 4 pounds. So, the rodent, big beefy rodent.
Not a small rodent, but not a beefy.
Identified as a new species, Ceratogallus cornutasagma. On its schnoz, its horns were 17 millimeters tall. Not nothing for a tiny little rodent.
I mean, a noticeable amount of horn.
Now, right, new species, it's got horns on its face, it's a little rodent. These are the only rodents known to have nose horns. This is just not a thing rodents do. These little rhino rodents.
It's something exceedingly rare today.
And brings up the question, what does a gopher animal need with a horn? Not real gophers, by the way. I keep saying it, horned gopher. They're not actually gophers either.
What does a rodent need with... Why?
Why do you have a horn? Suggestions have been put forth. As listeners, you may already be filling in. Possibly for display.
Yep.
Possibly for competition. Possibly for defense. Possibly to help with burrowing.
Yeah, that was, I think, my first thought I ever saw a picture of one of these. I could see you snooting out dirt with that.
And these rodents, lots of rodents are burrowers. The ancestors of these, some of these rodents, this group, are burrowing rodents. So it certainly could be that you're pushing dirt out of the way with your face. This study compares the 6th horned species over time to look for trends. And here's what they found. The earliest horned species had typically smaller bodies and smaller horns, and the later ones were bigger with bigger horns.
Okay.
But the horns and the bodies were not proportionate to each other. The later and larger they got, the proportionately larger the horns got.
Alright, so the horns were increasing in size quicker than the body was.
Yes, so we talked in episode 33 about ontogeny. I believe you brought up the concept of allometry.
Yeah.
And allometry means that different body parts are growing at different rates. So compare a baby human to an adult human, our bodies are differently proportioned. The bigger these rodents got, the larger their horns got. The new species is right in the middle. It's about 10 million years old, and its horns were medium. The largest ones had horns that were 33 millimeters. It's a big horn. So, why might you need a bigger and bigger horn the bigger you get. A similar pattern is apparently seen in certain horned lizards.
Oh.
Which use their horns for defense. The idea being, the bigger you get, the bigger a target you are, the more time you're spending out on the surface instead of burrowing, the more exposed you are to predators.
I mean, it makes sense. Part of being small is that you are a smaller target, but also easier to hide.
Yep. And you're not as much food.
Yes, you're not quite as appeasing when you're a chicken nugget versus a whole tender.
And they also point out that around the time we see the evolution of these horned rodents, North America also sees its first skunks, badgers, and buzzards.
All right.
So there were also new predators on the scene. Now they compared the ancestors, but without horns, of these rodents to the trajectory of the horns, and they find that some of the burrowing versions have thicker nasal bones. So what it looks like probably happened is that they had these thicker nose bones, probably to help burrowing, that then got bigger and bossier, and then became little horns, which became medium horns, which became big horns, as the need for those horns changed. Originally, you had a nasal bony bump to help you push through the dirt, and then, hey, you remember exaptation?
Yes.
Episode 78? Well, now when you're going out on the surface, if you turn that bump into a little horn, now you are helping deter predators.
Cool. I like that. Like, I find this super interesting because of you have so many different features and trends going on with these weird rodents. You got weird allometric changes happening, as well as a weird feature for a weird group.
Yeah.
And that's... I'm always excited when we find a recognizable feature in the quote-unquote wrong group.
Right, a rhino horn on a rodent.
Yes.
Although I should be clear, rhino horns today are keratin.
Yes.
These were bony horns.
These were actual horns.
It's like a bison.
Mm-hmm.
Or a ceratopsian.
Yes.
It's like a ceratopsian horn.
Yep. So these are styraco rodents.
Yes, episode 87.
And I love that because you have that familiarity in a group where you don't know what to do with it.
Yep.
Like, obviously, or I guess maybe not necessarily obviously, but most likely they weren't charging across the field at each other to...
No.
You know?
Well, the way that Josh described it, he said, imagine... And this will be in the press release because I use it because it's a great line. Imagine an animal like a groundhog or a prairie dog sticking its head up out of the ground, and the first thing that comes out are the horns.
Yeah, exactly. And I could definitely see it just being... It makes you look less palatable. And
oh yeah, it could be a deterrent. You don't even have to stab something with it.
No, it's just that now you look harder to swallow. It's like
literally.
The horny lizards and stuff like that. Like,
oh yeah,
I've held like a bearded dragon. Like, if you hold a bearded dragon, it's not gonna hurt.
No, but I don't want to eat it.
Yeah, but that's gonna feel like sandpaper going down my throat. So it's stuff like that. It might just be, yes, I have a fish hook on my face. What are you gonna do about it?
Go away. Go eat that prairie dog.
Cool. Well, my first bit of news is about eggs.
Oh.
Dinosaur eggs.
Okay.
And particularly weird dinosaur eggs that may give us information about some of the earliest dinosaur eggs, some of what the early evolution of dinosaur eggs look like.
We currently have some dinosaur eggs down in the fridge.
Yes, we do. That we're gonna make some tasty meals out of. This is research by Mark Norell et al. In Nature, and the article is by Joanne Lindgren and Benjamin Keir in Nature News and Views. So, eggs, specifically amniotic eggs, which are the ones with an amnion.
An amnion. The ones made for laying on land.
Yeah.
Thick-shelled, hard-ish shelled eggs that you can lay on land. It's a solid
shelled that will not dry out.
Right.
That's really the key feature. And it's what lets tetrapods master the land.
Right. Reptiles, birds, mammals.
But there is another development within the amniotic eggs that differentiates or separates kind of two major groups, and you have the soft-shelled and the hard-shelled.
That's true. The ones in our fridge are hard-shelled.
Yes, like if you think of a chicken egg, when you hit it against the side of your pan to crack it, it hits it. You know, you actually will shatter it. Those are calcareous. They are calcium-based eggs, so they have a mineral that makes them that hard. And that is your typical bird egg, and many dinosaur eggs.
Yes.
Are fossilized and show mineralized shells. But things like a lot of lizards, snakes, and turtles don't have those calciferous shell.
No, they have leathery eggs.
It's much more leathery. So it feels... water balloon's not quite right, but a thick pouch.
Like a football filled with fluid.
There you go, yes. And so this still keeps them from drying out, still protects the young, but it doesn't have that hard and very consistent shape. Or for instance, like when turtles lay an egg, it comes out perfectly spherical like a ping pong ball, but if it bumps against something, it can dent.
Right.
And that's fine.
It deforms a little bit.
It deforms just slightly. So there has been some questions and some debate as to how did evolution between these two forms happen, because soft-shell eggs don't typically fossilize. They're not minerals already, so they're not pre-made to fossilize, and they rot much more readily. So we don't have a lot of soft-shell fossils, and basically all the dinosaur egg fossils are calcium-based, but there are some gaps. Most of the dinosaur eggs we have are from a few major groups, but not all of them. Your most common ones are things like the big long-necked sauropods, carnivorous theropods, and your duck-billed hadrosaurs. But those are the main culprits. You know, you're not finding it from some of the other more obscure groups or the earlier groups, potentially, because we also have found that most of the dinosaur eggs are Cretaceous, so fairly young for dinosaurs.
Right, geologically.
Exactly, like toward the end, not toward the beginning. The fact that birds and crocs lay hard-shelled eggs has leaned the hypothesis toward this is probably an archosaur thing. Hard-shelled eggs is, archosaurs laid hard-shelled eggs.
Right. Birds, crocs, dinosaurs, pterosaurs, probably all the same.
Yes. But there was another little puzzle there, because the microstructure is very different between many of the groups. So it's not the same mineralized structure, which suggests potentially different evolutionary paths.
Right. That hard-shelledness evolved multiple times with different structures.
That it didn't have one origin necessarily, it might have had multiple. This study describes a multi-million-year-old soft-shelled dinosaur eggs.
What?
And that's why it's a big deal. These are soft-shelled, like, in the images of them, you can tell because they're folded and, like, dented, just like we were describing. And there's two different eggs from two different dinosaurs, from two different ages. One contains an embryo of a sauropod, or sauropod-like dinosaur, called Musaurus, which is a late Triassic aged, so you're around 200, 220 million years old. And the other is a Protoceratops egg from the late Cretaceous.
Oh.
Yeah.
So a little ceratopsian, a little cousin of Triceratops.
Yeah, a little frilled dinosaur. These eggs allowed them to computer generate an evolutionary model, and the model suggests that the scarcity of dinosaur eggs pre-Cretaceous, so older than 145 million years ago, could likely be a reflection of poor preservation of soft-shell eggs.
So if early dinosaur eggs were soft-shelled, they're just not fossilizing.
Exactly. So that the missing early records could be because more dinosaur eggs were soft than we might have initially suspected.
Intriguing.
They took a histology of the eggshells, which is
tissue analysis.
Yeah, where you take the thin layers, and it showed that it's similar. The layering, the arrangement is similar to turtle eggs.
Oh,
so very, very recognizable to some of our today soft shell eggs.
Interesting.
They also compared both of these eggshells to other diapsids, which are the creatures with two holes in their skull, which dinosaurs are a part of.
Yeah. Lizards, snakes, crocodiles, pterosaurs.
Yeah. And it supported that, the earliest dinosaur eggs were very likely soft-shelled. That this isn't something these groups evolved, it is the ancestral state.
And then later down the line, some groups, perhaps, evolved harder eggs.
Exactly.
Huh.
And, in fact, the research suggests at least 3 times. 3 separate times within dinosaurs that calciferous eggs were evolved. It looks like hard-shelled eggs is not the original state of dinosaur eggs, that it evolved multiple times, and in fact that soft-shelled eggs likely were much more common than not within dinosaurs.
That is very interesting because most of the studies that I have found comparing dinosaur nesting habits, or trying to understand dinosaur nesting habits, compare them to birds and crocs.
Yeah.
And so if they had perhaps, for example, turtle-like eggs, that might change how we understand a lot of nesting habits, especially in earlier dinosaurs.
Absolutely. They mentioned that with soft-shell eggs, they're much more susceptible to heat exchange.
Right.
So you can bury them with some rotten plant, and that will keep them warm. You don't need to brood, and you don't necessarily need to nest the same way around them, which is what turtles, and it's what crocs do.
Yep.
You definitely could have maybe more actual burying of eggs or something like that. So, yeah.
Cool. Now I have this image of... One time, many years ago, I was on a beach, and I was walking along the beach, and I came across a mound where a sea turtle had the night before buried a bunch of eggs. And I know that it was a sea turtle mound because the drag tracks from the tide line were still in the sand.
Yeah, the little tread mark of the flippers.
Where Mom had dragged herself up. So now I have this image of walking along a beach in the Jurassic period and coming across a giant mound full of dinosaur eggs.
Well, and it also... Because something I always used to wonder with some dinosaurs is, unless you have a structure to get your giant body much closer to the ground, it seems like your eggs would be in major danger.
Right, if a sauropod is laying eggs and dropping them 10 feet down to the ground. Right, I've done that experiment in school.
Yeah, you need a bunch of straws and toothpicks around it. But like a turtle, if you ever seen a video of a sea turtle laying eggs, the eggs actually off of each other.
Oh yeah, they're bouncing around.
Fine, because they're soft.
Very interesting. Well, since Will mentioned that soft-shell eggs are extremely rare in the fossil record, my next bit of news is about a soft-shell egg in the fossil record. Yep, that's what we got. This is research by Lucas Legendre et al., also in Nature, and we'll link to a press release through UT News. In 2011... researchers excavated a strange fossil that became known, apparently, as the Thing. It came from Antarctica.
I love the Thing.
Very late Cretaceous, 68 million years ago, from near-shore marine environment. And it's this sort of weird folded-looking shape that this paper identified as an egg.
It looks like, to use your comparison, it looks like a deflated football.
Yes, it does. And it's huge. It is 7 by 11 inches long.
So, actually like a football.
Yeah, no, it's this deflated football-sized thing, which makes it the largest known soft-shelled egg ever, and it seems the second largest egg, period, next to elephant birds, which are slightly larger.
I can't help but picture that thing being laid and then just sloshing like a waterbed.
Yeah,
it's just like
a giant water balloon,
and the baby will move around and it'll slowly walk around.
Another major difference between this and a elephant bird egg is that, as Will was describing, elephant birds are dinosaurs, and theropods tended to have hard-shelled eggs.
Yep.
Elephant bird eggs are, the shell is about 5 times thicker than this soft-shelled egg fossil, which has this very thin shell. So, record-setting soft-shelled egg, awesome. Next question, whose egg is this?
Seriously?
'Cause here's the thing, everybody. This is the size of it. The only animals we have ever seen lay an egg this size are dinosaurs, elephant birds, and then the runners-up for big eggs. But though this is latest Cretaceous, there were big dinosaurs around. It is, one, too big to be most dinosaurs, and the shell structure is different. So even given this new information about knowing about soft-shelled dinosaur eggs, it does not have the right shell structure to be dinosaur. Instead, what they found is that the most similar comparison is lepidosaurs.
Oh.
Lizards and snakes, and tuatars. So what they did is they did a comparison. They said, all right, well, let's look at the size of eggs laid by a variety of reptiles and estimate how big a reptile would have to be to lay an egg this size. And their analysis suggested that the layer of the egg should be at least 7 meters long.
That's
so like 25 feet long.
Yeah, it's a decent amount of meters.
That's a big lizard. And as it turns out, there were 25-foot long lizards in the latest Cretaceous. We talked about them in episode 51. They are called mosasaurs.
Indeed.
They are the aquatic lizards. And indeed, in this same formation, researchers have found baby mosasaurs and baby plesiosaurs, episode 72, which were the often long-necked aquatic reptiles.
Yeah, four-flippered.
Yep. So they're saying, all right, well, it's soft-shelled, like a lizard would be. Plesiosaurs are also not dinosaur, also big, also not dinosaur, closely related dinosaurs. So they're leaning mosasaur. But, as we've discussed in those other episodes, our understanding is that those big aquatic reptiles gave live birth.
Yep.
So what's the deal? Now, I have seen a number of people online, paleontologists, referring to this study and saying, I don't think it's a mosasaur egg. Like, that's not a hard and fast, definite, their size comparison. Elephant birds are smaller than T-Rex.
Yes, they are.
So the size thing is not necessarily a definite measure. Also, there's always the possibility that there are animals around that we haven't learned about yet. But this paper at least seems to favor the suggestion that maybe what we have found is a soft-shelled marine reptile egg.
Findings like this are always so intriguing because it's an amazing finding. Like, whoa, that's a giant...
Oh, it's super cool.
That's so cool. But it also is kind of one of a kind. Like, we don't have another comparably sized soft-shell egg from this time period.
No. Or any time period.
Or any time. Like, we don't have... even something that's a couple of magnitudes down. Like, even something that's the next size... We don't have colleagues to compare it to.
Mm-hmm.
So you're using one really cool finding, and the study did an awesome job pulling as much information as one could by comparing the structure and comparing the size and estimating the size of the layer, the one who laid.
Yes.
But it's one example. And were we to be, if elephant birds had gone extinct long before we had good evidence of them, and we only had an elephant bird egg, we might be sizing them to T-Rex.
Or bigger.
Or bigger.
Oh my goodness.
Like, this has to be a sauropod-sized theropod. Like,
right.
It could be very easy that we're judging it based off what we know, which is what you do, but we could just be missing that, there was a really weird single big egg-laying reptile.
Right now, I have an image in my head of some weird Cretaceous lizard that had eggs like a kiwi.
Yes, exactly. That's just kiwi was the other one.
Body was filled.
Yeah, it's just got these big hips with a big old egg in it.
Now, they did make the point that, okay, if these marine reptiles did lay this egg, how would they be handling that?
Yeah, how are they getting it onto land?
And they mentioned two options. One is that apparently... And the paper, I couldn't get access to the paper, so I couldn't find their reference for this. It mentioned this in the press release, I believe. Apparently they say there are sea snakes that lay their eggs in the water and then the eggs hatch really quick.
I didn't know about that.
I don't think I've heard of that. So maybe, or that this idea of having quote unquote vestigial egg, like an egg that's there for just a bit, but it's not really, you're basically giving live birth.
Yeah, you haven't functionally gotten rid of the egg, but you are effectively giving live birth.
Right. Or, on the other hand, the sea turtle strategy, which is you go up onto land and lay your eggs. And there is some discussion of, all right, are they dragging themselves onto land like a sea turtle? Are they, like, flipping their tails out of the water,
yep,
during high tide and laying some eggs and then swimming away? like you said, this is a one-of-a-kind find. More data needed, I suppose.
And we run into the other issue of, you know, for a long time, kind of the supporting idea, one of the supporting ideas behind, these gave live birth is the fact that most of them don't seem like they have the capability to come on land.
Right.
Like, they really don't look land friendly.
They're real big.
And they're just the body, you know, like a lot of them, the limbs don't seem like they have the strength to move.
Right.
But I would, once again, were all sea turtles extinct, would we say they could come on land?
Right.
Because I've worked with sea turtles. Like, I've not worked with them, but I've worked across the glass from them. And they sure don't look like they should be able to come on dry land. They're big and they're real graceful in water, but they don't look like they'd be graceful on land.
And there are also, like, dolphins that'll beach themselves.
Yeah.
And then, you know, like...
Was like, could it beach itself during high tide and then wait for the next high tide to get back? Like, could it survive half a day between tides? Or, you know, like...
Or are you big enough that you can stick half your body out of the water, lay an egg, and then swim yourself back away? So that it's not out of the question.
Yep.
But we'll have to see what else comes up in the future.
For sure. Last bit of news that I have is about a bipedal croc cousin.
Cool.
So trackways found that indicate a not two-legged, but two-legged walking croc of some sort. This is research by Kyung-Soo Kim et al. In Scientific Reports. The article is a press release by the University of Colorado, Denver in SciTech Daily. This trackway, a trackway being a trace fossil of footprints left behind by something
that walked.
Something that walked, usually. This was a trackway from the Cretaceous found in Korea, and tracks look like crocodilomorph. Crocodilomorph being the overarching group that includes both the modern crocs and all of the gators and stuff, as well as all the ancient relatives that are croc-like, crocodilomorph, but not actually crocodiles.
Episode 2.
Yeah. These are actually abundant tracks. They found quite a few of them, and they date back to about 110, 120 million years old.
All right. Early Cretaceous.
Early Cretaceous, and seem to be from a bipedal crocodilomorph.
All right. We've heard of those before.
Yeah. Walking around on its hind legs. The thing that makes this stand out a bit is that it seems big.
Ooh.
So, this is the Lower Cretaceous Jinju Formation in South Korea, and it is a site known for its tracks. They've got them all over the place, evidently, there, which is cool. They said so rich that you can read the entire ecology.
Cool.
Which, I want to go there now.
That's awesome.
These tracks are between 18 to 24 centimeters long.
Each?
Each.
Ooh.
And that's why it's not a small crocodilomorph, which we've known about bipedal crocodilomorphs, but usually the terrestrial ones are, most of them are fairly small, and the ones that seem like they were more agile and bipedal are often smaller. This one looks...
And since we've switched between metric and non-metric measurements, that's about the size of that egg.
Yeah, there you go. There you go. This gave them the rough estimate. You know, you're dealing with just footprints, so I mean, it could have been a really big-footed crocodilomorph. But
for running across water.
Yeah. This gave them the rough size estimate of a crocodilomorph, probably predator, around 3 to 4 meters long.
It's not nothing.
So that's like a American alligator, standing up on hind legs and walking around like that. Whew. So this is a apex-sized predator, which is what got their attention.
That would get anyone's attention.
The tracks were given ichno identification of Batrachopus grandius to emphasize how big it is.
Grand.
Fossil trackways like this, similar to this type, have been commonly found in the Jurassic of North America.
Okay.
So these are not new to our knowledge, but the fact that it's in Cretaceous is significant. Crocodilomorphs were potentially going to be the dominant land group in like the Triassic, and then dinosaurs kind of came in, and it was often assumed that they took over the main role of big terrestrial predator.
Right, now you've got a bunch of allosaurs and tyrannosaurs and stuff walking around. there's no more room for big bipedal predatory crocs.
You get to go be big in the river.
Right.
But this is a 3-meter predator on land in the Cretaceous.
Yeah.
So perhaps it was not so one-sided as we initially thought. So it gives us some interesting insight in that. And then also the tracks are evidently really good. They are detailed enough to get skin impressions.
Ooh.
Foot pad impressions.
Ooh.
And is enough to give them an indication of the bone structure of the foot.
Wow, that's cool.
So it's good footprints. And what gave them the hint that it's bipedal, other than there being like two, but also the narrowness. They were not sprawled. They were close together. So this was walking much more like a dinosaur.
Right, with a more erect, a more parasagittal posture.
Yeah.
Legs under the body.
Under the body, like us. There were also parallel pathways to the tracks from other individuals that could potentially be a suggestion for group travel.
Mm-hmm.
That they were moving together, whether they were social or whether it was, a pack. That we can't tell, but subtle evidence for a social aspect to these animals.
It's pretty cool to have this image. What paleo artists?
Yes,
I'm excited for images of theropods and bipedal crocs walking around the same places in the Cretaceous.
Well, it's a cool idea to have like two groups of major predators. It's like if you got to see a Komodo dragon and a wolf fight over a carcass.
Well, in the ocean in the late Cretaceous, you have your mosasaurs, your plesiosaurs, you have big sharks. There's a lot of different big marine predators.
Mm-hmm.
And on land, it's like, dinosaurs. Now, obviously, there's a diversity of dinosaurs.
Yes.
But it's cool, too, that there was at least one croc in the Cretaceous also doing this.
Standing up against the dinosaurs. Literally standing up against
standing up against them.
I also thought this study was cool. This is kind of a side note, but this was a truly international study because it's fossil trackways in Korea with researchers from Korea, but also Australia and the University of Colorado, Denver.
Neat.
So yeah, cool collaboration.
That is very cool.
And that's going to bring us to the end of the news.
You know what that means.
We get to talk about living fossils.
Oh.
So after this short break, we're going to learn exactly what you're typically told a living fossil is.
What? let's learn what a living fossil is and what it isn't.
Yes. So it's moments like this that I often wish we could instantly poll our listeners, because I would love to be able to ask everyone listening right now to give your definition of a living fossil.
Yeah.
Because I'm pretty I would be shocked if we didn't get a wide variety, and if almost everyone didn't have one that they have heard. Living fossils are a term that typically, this is the Wikipedia definition, refer to extant modern taxon, so groups of life, that closely resemble organisms only known from the fossil record. Typically in their own lineage. Not always. But for the most part, it's when a fossil species seems to have persisted in at least shape and appearance to the modern day.
Right. When you can take this living species and this fossil and hold them next to each other and go, wow, it looks very much the same.
Yeah, if you had the silhouettes, you could mix them up and people wouldn't know.
Right.
That's kind of the main idea. Now, there are more specifics than that. And a lot of times, I'm using the Wikipedia one because it gives the definition fairly confidently. And that's what you'll see happen a lot of the time. And this is going to be part of our discussion. But they say there are two main characteristics with a third that is sometimes there. Your two main ones is that the living organism are members of a group that has remained recognizable since its time in the fossil record longer ago than young fossils. It's kind of like how we've talked about there's not a agreed upon age for how old you have to be a fossil. There's not always an agreed, but that you have fossils going back a ways that still look like you do now.
Right. The Miocene, the Eocene, the Cretaceous, the Cambrian, this looks like what we have now.
Mm-hmm. And that they show low morphological divergence, that they have not changed their features very much. So it's not just that you look like, yeah, it's a turtle and it's a turtle, but this one's got like a smooth shell and that one's got a... Like, no, they still have most of the same features. And the third one that is less commonly, not always included, but often comes up, is that the modern group has low taxonomic diversity. There's not many of them.
Right. Usually when you hear living fossil, it's satisfying to point at a species.
Yes. This group that has 2 species in it, or
right.
1 species in it.
It's less common that you would hear and less interesting for the purposes of the term to go, yes, these 2,000 living species are living fossils. And it doesn't quite work that way.
Usually if you have high diversity, it starts to undo the second one of, if you have 2,000 species, it'd be real weird if they all also look alike.
Right, exactly.
At some point, you start looking different. Now, that's the kind of quote-unquote more official definition.
The semi-official Wikipedia version.
But there are, like, your more catchy definitions, which is what you'll typically hear on, like, a documentary, in that a living fossil is a species that has gone unchanged for millions of years, or since the time of its fossil ancestors. And those definitions are where we run into lots of problems.
Right. It's the pithy version. Mm-hmm. Unchanged. Time has stood still for these animals since 100 million years ago.
And that's not to say there aren't issues with the more official, but we run into major issues there. Now, how this term gets used, because we're defining it, but why do we need this term? Often this is a way to identify unique animals. It's not an official categorization.
Right. This isn't something you're going to see in like a lot of scientific papers.
No.
We've identified this as this family and it is a living fossil.
Well, it's like, if I could have a book with a chapter on sanguivores that drink blood, but I'm not usually going to have a chapter on living fossils because it's not actually a thing.
It's not an official description.
And it's not similar between all the groups that are described that way. They're all living fossils in their own way, usually. So it's usually a way to identify unique groups, unique taxon, unique species.
Right. And it's used very colloquially.
Mm-hmm. And it's often used as one article had a quote that was, as an informal window to the past.
Right.
That a lot of times, and this is where you can start getting into weird territory, it's used as here are potential examples for past life. The lungfish looks so much like ancient things. Like, that is where it can get very pithy very quickly. So let's jump right into what are some of the issues, because that's going to color the whole discussion of our episode. So let's go ahead and why is this controversial?
Right. What's the problem with this idea of a living species being a window into the past?
Yeah, and what are the complaints levied against it? The biggest one levied by scientists usually is that it's poorly defined.
Yeah.
The definition is not clear. Even the definition we gave at the beginning, that doesn't actually, like, what do you mean morphologically similar? Like, how similar?
Right.
And what do you mean not recent?
Yeah, exactly.
Like, it's not clearly defined, and even worse than that, the definitions are not consistent. What even different researchers define a living fossil as, if they decide to use it in their paper, is not usually the same as when it's used in another paper, or when it's used in another book, or by another writer or documentary.
Right, which is why if you do see it, you rarely see the term in scientific papers, and often when I see it, it's in quotation marks.
Exactly, and that is
this admission by scientists going, hey, this is a colloquial term, but there's not actually a definition, so we're not using it in a scientific sense.
That was even pointed out by one of the papers I read as those quotation marks being an almost admittance by the scientific community that it's not a good term.
Right. And you will notice that in the title of this episode.
Yep. We used them too, because feel a similar way. But there have been papers that have tried to kind of collect how has it been defined. And from what I was able to find, there's almost 10, there's up to at least 8 different factors that people have used to define living fossil groups.
To try and solidify the definition of this term.
So, just very quickly, we're not going to discuss each of these, but just so you have them. Prolonged geological duration or persistence of a lineage, so you're around a long time. Morphological similarity to fossils from the distant past, you look the same. Those are basically the same as Wikipedia. Slow rate of evolution is often a feature, a more specific version of you look similar. Low taxonomic richness, that's the diversity, that was the third thing. Small geographic range, not just that you have few species, you're not very found many places. Genealogical divergence in a very distant past. Your species diverged a long time ago, and then you've been in that group since. You haven't split off again. Presence of characters that seem ancestral, plesiomorphic. So things that we would describe as old-looking, effectively.
Well, yeah, features that we infer were present very early on in this lineage and its cousins.
And then, this is a big one, often known from fossils before they were known in the modern day.
Right, which is what makes some of them so famous.
Yes. And there's also just, a lot of times, just the description of primitive traits, which is a problematic description of traits.
Yes.
To begin with. But you will see it show up.
That's another term. And we've mentioned this before, this question of primitive, which is this older term to describe early traits.
Yes.
Ancestral traits. But these days, a lot of scientists don't like using the word primitive because it carries other connotations with it.
It has a bit of a quality that you're qualifying the trait, and you shouldn't. People have pointed out numerous issues. That's a lot of features. And basically no living fossil group matches all of them. And there are some that disagree with some of them. And under at least a few of those, we could potentially...
Yep.
Groups that don't make sense could count. We've looked like humans for into the fossil record.
Yep. We are the only living member of our lineage.
Yep. So you have so many features that you're casting a very wide net that's very unclear and sometimes almost disagrees with itself. So the definition is problematic. And that, along with just the term itself, it's confusing. And not necessarily for scientists. If you're studying evolution, if you're studying fossils, you already have a pretty good grasp of how living fossil is used because you've been introduced to it 12 times. But if you're a person visiting a museum, if you're a person reading the news article, if you're a person not within the scientific community, living fossil, without having it defined for you, already kind of suggests a definition.
Right.
This is a fossil creature that has either come back or never went away.
Right. Pokemon style.
Yeah.
A literal living fossil.
And so it is very easy for this term to send mixed messages to the public and to potentially send counter messages, things that actually go against what we're trying to teach in those facilities. And so that's often a criticism of it, that this is a bad teaching term. It's just not useful. It's not conducive to getting the concept of evolution and fossil history across to the general public. And on the extreme end of that, it actually can be used against us.
Because of that lack of clarity.
Yes.
Yeah.
Because of the catchiness of the term and the unclearness of the words we're using with it and the bad definitions that we have for it, it has often been used by creationists and evolution deniers to say, well, if you've got living fossils, how in the world can you claim they're evolving?
Right.
You just said it's the same as the fossils.
I had a guest come up to the front desk at the museum once, many years ago, and said, so you said that the tapirs at this site look just like tapirs today. Mm-hmm. It's like, yes. Well, what happened to evolution?
Yeah.
And it's that idea is, your whole shtick is that things are changing over time, but here's an example which you're openly admitting that things aren't changing.
And it opens the door for not legitimate, but lots of attempts at gotcha moments. Aha!
Well, and they're very catchy.
It is.
It's a catchy term. If you hear a term like that and you think you understand what it means, because it sounds pretty self-explanatory.
Well, it's like the bird-hipped and lizard-hipped dinosaurs.
Yeah.
Those are bad names.
Yeah, you did a bad job. Or Or, soapbox moment,
Yeah.
we should put less emphasis on translating Greek and Latin terms for people for the definitions of dinosaur words, because they don't make sense. They're confusing. But anyway.
Yes, it's stuff like that.
it's catchy. I mean, you hear it in movies and stuff all the time. It gets stuck in people's head, and it's easy to think you understand something, and thus easy to get pulled down the wrong track.
And that kind of brings us to, at least for a lot of scientists who argue against this, a core issue of it. Because a bad definition is something you can adjust.
Right.
But
fossil is not a wonderfully defined term.
But there have been terms like that have gained niche, definitions over time, as someone finally went, you know what? This term means this. And everyone goes, you know what? Yeah, it does.
Yeah.
But a lot of scientists, a lot of researchers complain that the concept using the term living fossil and focusing on the attributes the way it does is actually counter to an evolutionary mindset. It actually works against you thinking of this as an evolving creature. Because, of course, they're not going across a million years just not evolving. That's not how evolution works.
And even if you are retaining similarities through time, it doesn't mean that there's no evolution or no change happening.
Exactly. Like, this can potentially work against you thinking in a mentality conducive to viewing their evolutionary history in a realistic way.
Right. It puts a preconception in your head.
It does. And there's been lots of researchers who have pointed out and called studies out for your conclusion. I don't think you would have come across if you weren't already calling them a living fossil.
Mm-hmm.
There are other conclusions that you might have come to had you not had that preconception in your head. And that's often a finger pointed at some of the studies supporting the term or using the term more readily. And the point a lot of them make is that in the past, it might have made more sense to use the term because we didn't have a full understanding of how evolution works on the different aspects of an organism. But nowadays, just because I look the same on the outside doesn't mean I'm the same on the inside.
Mm-hmm.
It doesn't mean that the things that didn't fossilize, soft tissue, organs, behaviors haven't changed, and you don't have my genetics.
Yeah.
So you have all these things that very likely are evolving and almost certainly are evolving, but that you actually can't see. So you're using a limited set of features to then put a label that is going to a degree, indicate it's not changing much, when it very likely could have been. The examples I thought of to give you an idea of why this is problematic is like, if you take smartphones, was the first thing I thought of. If you take the first touchscreen smartphone that was ever made and the ones today, they look different, but they pretty much look the same. Like,
an alien would go, yeah, that's the same thing.
It's the same thing, but internally, unrecognizable.
Yeah.
Like, the materials, and like, if you have tried
this one plays Snake.
Yes, exactly. This one plays Snake, and I can take a grainy picture.
Yeah. This one has Netflix.
Yes.
The example that comes to my mind, because I would be fooled by this, is cars.
Yes.
Like, if a car person pointed at two cars and was like, that one, the specs on that one are just off, so much better. And I'd be like, well, they both have 4 doors.
Well, I've had that before.
4 wheels.
I've had car friends before point at 2 cars that were like 2 Mustangs. And they have basically the same shape other than like, oh, that one's got stripes there and this one's blue. And they're like, that's worth, $50,000. That's worth $100,000. It's like, why?
Yeah.
Because of a list of things on the inside that make that a supremely better car. And it's like that. This term kind of counteracts that sort of keeping that in mind and that thinking.
Well, and for me, it's especially something that I think of from an educational mindset.
Mm-hmm.
And I've heard a lot of educators have complaints about it, is that one of the things you learn if you're an educator is one of the hardest parts of learning things is often unlearning the thing you got wrong beforehand.
You must unlearn what you have learned.
Right. If you have this idea lodged in your brain that there is such a thing as a living fossil, that's going to clash when you're trying to learn about actual evolutionary processes.
Well, and it also is the same reason that when you're educating, you choose your terms and your word usage very carefully. At the aquarium, we didn't call them jellyfish. They were jellies. We didn't call them starfish. They were sea stars. Like, because they're not fish, And you might be like, okay, oh yeah, but I know they're not fish. But you might.
Right.
I have a list of people I've met that don't.
Right, and the words you use are important. And
It's
when you're
how we
trying to communicate with people, it's important to avoid confusing terms as much as you can.
Yes. Now, after this session of us just taking the knees out from under,
we don't like the term. This is not an episode for us to just rant about the term. No. But this was the part where we complain about it. And yeah, we have complaints.
Yes. There are those in defense of the term. As you mentioned, there are people who do like the term and come to its defense, and there is at least one that I could find. I couldn't find any other, like, specifically coming to the term's defense. But last year, 2019, there's a paper by Derek Turner in Biology and Philosophy making a case for living fossil. And they did a few things. Some of their focus was on addressing some of the complaints and basically saying, here's the complaint. Here's why they have that complaint. Here's my response. Here's why I say it. Basically, my reasoning that it's not that big a deal for these reasons. You know, to look at it from this point of view kind of thing. And I'm not going to go through every single one of those because it's a long paper, but it will be up. But
it'll be in the blog post.
What they did do that I want to make sure to mention is to make a more specified definition that they proposed as we can keep the term living fossil and use this more clearly stated definition, which they call the phylogenetic concept of a living fossil. So using phylogenetics, using classification. And it has 3 features. Prehistorically, deep morphological stability, which is it's a stable form, you know, body plan or physical shape over deep prehistorical time. They do point out that this can be difficult to confirm if you don't have a good fossil record.
Right.
And so that is an issue a lot of times with living fossil stuff, is if you're missing fossils, it muddies the water now as to how clear your evidence is. Few extant species. They include that they are at least rare in their diversity, if not numbers. And high contribution to phylogenetic diversity. This is an interesting new one. This is them saying that the group must be unique when taking into consideration the overall biodiversity of the area or globe.
Right. So this makes me think of when we talked about New Zealand, episode 86, tuataras are 1 asterisk species.
Yes.
But are way distant from anything else. They are their own group. If you have 7 lizards on one island and then the same 7 lizards and a tuatara on another island, that second island has way more diversity on it because of how distant tuataras are.
Exactly. And this is an important feature, they said, because this can often be used for conservation consideration. Biodiversity, you know, the amount of different kind of animals you have, is one way to measure diversity of an ecosystem, but also, or species, life, but also phylogenetic diversity. How far on the ladder of life is this ecosystem reaching and covering? And there are conservation efforts that use that as their method of determining where to conserve and where to put forth effort. There's actually an organization called EDGE. It's the Zoological Society of London, and it is the Evolutionary, Distinct, and Globally Endangered, is what EDGE stands for. They're looking at species that are unique and threatened and focusing their efforts on them. So that's what this concept is really focusing on in this definition. So a more robust definition, I definitely would say. And they propose that to try to help defend the term, and also point out that this term can be important for drawing our attention to interesting evolutionary questions. If we have a group that seems to be very, very similar to a fossil group, then pay attention to it, because there might be an interesting thing going on there. And so they say that's a good thing because it draws our attention to places that it might be needed. So, and they, like I said, they have a whole section where they kind of go part by part and make a response to some of the complaints. So the term is not without its supporters.
Right. There's a discussion.
Yes. Now, that being said, there's also an article that was written saying we should make the term living fossil extinct.
Is it the Guardian article?
Yeah. So, like...
Which I think was last year?
Yes.
Sometime very recently.
So there are counter articles trying to do the exact opposite.
Right. Getting people to stop using it and move on.
And that is by far the more common stance you'll find.
Yeah,
and
I've heard that argument way more often.
And there are more papers that are not necessarily focused on debunking living fossils, but that part of their conclusion is, and this is why this thing isn't a living fossil. So stop calling it that because it's a bad term. And like, that is your more common. But there are people on the other side, and there is still a discussion going on. And obviously the term's not dead.
Right.
Because we're talking about it.
You saw the title of this episode and you went, oh,
yes,
I know what that is.
So very briefly, let's go through the history of this term before we start looking at some of the examples, some of the classic living fossils, and discuss where they may or may not be.
Yeah, what nincompoop came up with this term anyway?
And it's older than the nincompoop you think.
Oh, interesting. See, that's the same joke I make every time living fossil comes up.
Yeah.
That's a funny joke.
And so... classically, you will hear that it was coined by Charles Darwin on Origin of the Species in his book discussing creatures that seem to have remained very similar, specifically within freshwater environments. Mm-hmm. And we'll go over that in a second, but the term does predate him.
Oh?
Just has nothing to do with actual fossils or evolution.
Oh.
So, going back to the 17 and 1800s in Europe, miners had stories, as workforces often do. And many of them had stories about living animals emerging from spaces in the rock.
Okay. Like The Descent.
Yeah, kind of like that.
Rain of Fire.
Well, and it was also connected to the whole, like, spontaneous generation idea of, like, yes, there are creatures that come from the spaces in the rock. Like, that's...
Right. That's where they are birthed.
That's where they come into existence. Often, for whatever reason, things like frogs and toads. Okay. And it is actually sometimes known as the toad in a hole phenomenon. And it was prominent enough that people and writers were talking about it, and some writers that would report on it would refer to them as living fossils.
Interesting. Using
an older version of the term fossil, which is an interesting thing you find in the ground. Yeah. Just something from underground is a fossil.
Rock.
Yeah.
Rocks and stuff.
A cool rock, a cool piece of something.
That came alive.
And this is a living one of those cool things of something.
Interesting.
So it was non-metaphorical. It was literally a living thing came from the ground. Living fossil.
I wonder if Darwin knew that.
I'm sure...
I wonder if he had heard the term and used it in his book.
I'm sure, yeah. I'm sure there had to have been some knowledge. Well, it gets more interesting because many people thought that these creatures, like especially toads, once again for some reason, were antediluvian creatures, meaning they were buried and trapped in the rock during Noah's flood. Yep. So these are things that had been trapped since the time of Noah and are now emerging and coming back to the open world. So, in 1826, William Buckland conducted a series of experiments where took blocks of sandstone and limestone and carved cavities in it, and then took toads and put them in the cavities, and then sealed them in the rock. This is 2 centuries ago, so they didn't have rules. Yep.
There were no toad rules.
Sealed them up, and then buried them for a year.
You see how well they do.
And then checked up on them, and nearly all of them had died.
Nearly?
The ones that had survived were because the seal was not perfect.
Yeah, I figured.
In the limestone. So, Buckland tried again.
Well, listen, he was a scientist.
And fixed those naughty seals. And this time he killed all the toads in a year.
Way to go, Buck.
Triumph of science.
Hey, conclusion shown.
If you don't succeed at first, try again.
This reminds me, I was told by a croc researcher once that there is this idea that crocs can hold their breath for like super, super long times.
Yep, I've heard this.
And it comes from, I think, one researcher who chained crocodiles to the bottom of a pool of water.
And timed how long it took them to stop struggling.
Yep. 2 hours. They can breathe for 2 hours.
So technically, This is why you have to put your experiments through a board.
Yep.
To make sure you're not doing something horrific.
We have ethics requirements these days.
So that concept kind of went away, but we got our connection to the fossil record in 1856 when a widely reported and, as far as you can tell, widely acknowledged as a hoax at the time, news of a living pterodactyl emerging from the rock.
Whoa.
When railway workers blasted open the rock. And like I said, no one, it seemed, believed this.
So this is much more like Rain of Fire.
Yeah, this is
actually Rain of Fire.
We crack open a rock. But then we have Darwin using the term living fossil.
Episode 28.
And he was referring specifically to the platypus and the lungfish.
Mm-hmm. Animals that are... It seems like this is a representation of what used to be.
And the lungfish was very much like, yeah, this looks like fossil lungfish. The platypus was very much like, yeah, this looks like what the midway point between two groups of mammals should be.
Yeah.
They're a fuzzy, warm-blooded mammal that gives milk, but doesn't have nipples and lays eggs. And so the platypus kind of got roped into this because it looks like an intermediate.
Right.
In evolution.
It looks like something you should find in the fossil record.
Yes, exactly. And he is quoted saying, "These anomalous forms may almost be called living fossils. They have endured to the present day from having inhabited a confined area, the freshwater areas, and from having thus been exposed to less severe competition." So his idea was that certain organisms in more idyllic locations with less stuff going on,
and more isolated,
just have less reason to evolve because there's no pressures causing them to change. If you don't need to change, why would you? So that kind of brings us, not to the modern day, but brings us to where the modern version of living fossil comes from.
Right. That's basically the modern idea.
But it's not the only term like this. There are other terms that describe very similar things. Some have gone out of use. Some are still technically terms. Like, you'll still find them defined on scientific sites and stuff, but they're not used very often. Thomas Huxley.
Hey, Darwin's bulldog.
Darwin's bulldog was not always like super supportive of natural selection. He had his own ideas before he got on board.
Thomas Huxley was a human, by the way.
Yeah.
Darwin's bulldog was the nickname that he got. This wasn't like Darwin's pet.
Well, this is a very opinionated dog.
Maybe I should have said DiMaggio?
So he had this idea of what he called persistent form. He had this concept of there being forms that have stayed the same since they evolved in the past. Because early on, he believed in make sure I have it right, a non-geologic time when things took their shapes and then persisted and left fossils. So this idea that there was a period of evolution and then it kind of stopped.
Right.
And things that have persisted to today, keeping those shapes, are persistent types.
Okay.
And then later on, he read through the theory for natural selection and went, no, that actually explains why things wouldn't evolve a lot all the time. So
this is better, you're right.
That works.
Yeah.
You do have things like Bradytelic evolution, which was proposed by George Gaylord Simpson, who was a U.S. paleontologist in the 1900s.
Famous fella.
Famous. And this was a term he came up with, proposed, that just is slow evolutionary rate. Like, almost evolutionary stasis.
Right. It's not that you're not evolving, you're just doing it slow.
You're moving so slowly, no one can see that you're there.
Yes, exactly.
So you do have that. The two more common terms that you might see that can actually get either confused with or used synonymously with living fossil is relic species and Lazarus taxons. Relics are whenever you have something, a group or species that was more widespread or diverse in its past.
Gotcha.
Where what you have today is the dregs.
Right. Like the Tuatara.
Yep.
One specific organism or population of organisms left over from this grand rhynchocephalian diversity.
And that's one where it's both, because it can refer to area or diversity. Relic populations you now are only found here. You know, you may have only been one species, but you were everywhere, but now you're only here. And then relic taxons you used to be 500 species, and now you're 2.
Right.
This one is different because you can also have it, though, in the fossil record.
Right.
Where you can watch a group go from very diverse to much less diverse.
Right, like trilobites.
Yes.
By the end of the Paleozoic, trilobites were almost gone, whereas when they started out, they were super diverse.
So this one works throughout the timeline.
Astute listeners of our podcast will note that this is a description we have applied to lots and lots and lots of animals.
Because if at any point in your future you go extinct, you're going to be a relic at some point.
Yeah.
Lazarus taxons specifically deal with things around today because these are things that we thought were extinct and then discover to still be around. Lazarus being coming back to life. They didn't actually come back to life. We just finally found them.
Right. Lazarus, of course, famously for literature people referring to the Lazarus pits that Ra's al Ghul uses to come back to life.
And so this is that idea of Ra's was a fossil. And we didn't know. And if anyone out there is going, why are they saying Ra's not Raish? I learned it Ra's first way. The classic example of this are coelacanths.
Yes.
We knew about coelacanths in the fossil record. They were a famous fossil group of fish, and then a fisherman caught it, and we went, huh.
You want that story? Is in episode 83.
But there is one more term I wanted to introduce, because this is another fairly recent, within the last few years, term that has been proposed as a replacement for living fossil. It's
also the term that Dylan actually suggested way back in the day.
Which I'm glad he did, because I might not have found it so easily, because there is one paper that suggested it and one National Geographic article that
reported on the paper
a bit. Yes, exactly. This is stabilomorph.
Stable morph.
Stable morph. Stable shape. This was a study in 2014 focusing on a fossil horseshoe crab and its similarities to today's horseshoe crab. So, and we'll discuss that more when we discuss horseshoe crabs. But they proposed, instead of describing horseshoe crabs as living fossils, we describe them as stabilomorphs. A new term that is focusing not on these living organisms being the same as the fossil record, but that their morphotype, their features have persisted. And that's really the thing to focus on, because living fossils almost looking backwards. This is moving things forward as time tends to move. It is categorized by 3 criteria. Relative morphological stability of organisms in time and spatial distribution, the taxonomic status of which does not exceed genus level. So
a bunch of closely related species within a genus that are similar in shape through time and space.
Exactly. Refers exclusively to genera, genuses.
Okay, so you can't have a family of living fossils. You can't have a phylum of living fossils.
Mm-hmm. That have survived at least one great extinction, one great mass extinction.
Okay.
So it can't be something from 2 million years ago. Like, all our youngest stabilomorphs have to be at least 65 million years old.
Right.
And then you can keep going back. And typically occurring in contemporary environments.
Right. Still alive today.
Yes. But this term also can work with fossil groups. You can have
trilobites.
Groups that persist through a mass extinction.
Or 3.
Yeah. Or, however many. And maintain, or certain genera, certain genus within the group, maintain a stable form, a stable shape or features during that time.
Right. Your evolved life shape is good enough that you did okay through really terrible events.
So this new term is focusing much more on the fact that if they look so similar during that time, that's really a cry for how successful that morphotype is, how successful those features are, and that way of being evolved is, not that they are so much like their past selves.
Right.
And that's kind of the aim of this term in a lot of ways, is living fossil gives credit to the fossil, stabilomorph gives credit to the morphology.
Right.
And that's kind of the big deal thing here. And so they openly say we should replace it with this, and point out that under this new term, there are many living fossils that wouldn't count. So some good examples of stabilomorphs are Araucaria, which is a genus of conifers, evergreen trees, that date back to the Mesozoic. and still look very similar today and are a genus, once again. Lingula, which is an...
Brachiopod.
Yeah, it's a brachiopod. This is a classic living fossil case because there have been some brachiopods not just said to be like, oh, look the same, but have been said to be the same. Going back to their origins since the Cambrian.
Yeah.
Like...
all the way back.
All the way back. The issue with them being called a living fossil is that research has actually showed that the shape of their shells, so brachiopods are like clams, but they have mismatched shells instead of identical shells. The shape of their shell corresponds to burrowing lifestyles, not necessarily taxonomic grouping.
Right.
So we may have been attributing group similarity when really it's just lifestyle similarity.
Right.
But the genus does still persist long enough to be a stabilomorph.
Okay.
So even if you make arguments against calling it a living fossil, it might still be a good candidate for this term.
Right.
And then the one argument I saw against this term was in the National Geographic article, which said that they didn't feel it was quite as catchy as living fossil, which makes them nervous it wouldn't stand up to the fight.
Yeah, it's not good. It's not going to be pithy enough.
Exactly.
To actually replace living fossil in the popular mind.
So that's kind of the overview of the current situation of the term and the arguments for and against, the other terms like it. So now let's take a look at some organisms that have classically been considered living fossils and what the research says for and against that, and kind of what the story each of their individual cases are. The list of organisms that have been called or are commonly called living fossils is actually fairly extensive. If you go to the Wikipedia page, which will be linked in the blog post, you can find a fairly exhaustive list of your popular living fossils.
It gets thrown around a lot.
It gets thrown around a lot, and there's lots of creatures that have gotten onto it, and lots of plants and other organisms. We're going to go through some of the more famous or bigger deal ones, or the more common ones, and discuss yay or nay. You know, we are not going to come down to a conclusion, because you probably already know what our conclusion most of the time would be. But there has been research oftentimes to kind of see, is there actual support, or...
Right. Do these fit those criteria we talked about before?
Is this a deserved term? And the first one is one of the most classic, and the one that was the focus of the stabilomorph paper, the horseshoe crab.
Horseshoe crabs, very famous living fossil example.
And for understandable reasons, the horseshoe crab fossil record goes back 445 million years.
Oh yeah. This is the group that the Pokemon Kabuto is based off of. And Kabuto in the games is a literal living fossil.
Yep.
There's an entry in the Pokedex that says they were thought to be extinct, but a population was found living. This is like the quintessential group of animals for living fossil.
The pop culture example.
Yeah.
And it is actually, like, on the surface at first glance, it makes a lot of good arguments. The earliest horseshoe crab fossils are identifiable as horseshoe crabs.
Oh yeah. If you showed a person,
yes,
like, yep, that's a horseshoe crab.
They don't look like today's exactly. They look a little different. They're shaped a little more weird compared to today's. They're different sizes, but it's definitely a variety of horseshoe crab. They also have no close relatives.
Right.
So they are taxonomically not very diverse and distinct. They're most closely today related to arachnids, spiders and scorpions, but actually they're more closely related to, like, Eurypterids, the sea scorpions. Today those don't exist, and they are not a spider or a scorpion, and they're not crabs. We call them crabs because they're hard and they're in the water.
And they're also not related to horses.
Nope. They are not related to horseshoe feet or smiths. Like, none of those things. So they're weird, they're unique, they go back a long ways, and yeah, they do look very similar. In fact, in the stabilomorph paper, it describes a Jurassic specimen. Today you have the family that horseshoe crabs is found in is Limulidae, with 4 living species that are in 3 different genera. The most common that you'll see is Limulus, which is has the American horseshoe crab in it. A fossil horseshoe crab, 148 million years old, so nowhere near as old as the oldest ones. From the Jurassic is also in Limulus. It's Limulus darwini.
All right, same genus.
Is the oldest representative of this genus yet found, and the fossil looks identical to today's juveniles. Identical. Yep. They said it is basically indistinguishable from the modern species, because there's only the one species in today's genus. It's Limulus polyphemus. And they look, at least when ours today is young, they look the same.
Right. At least based on what is preserved in the fossil.
Yes. So if we didn't already have good reason to call them living fossil, this is yet one more. But this was also what inspired them to come up with the term stabilomorph.
Right.
Because really it's not that they've not changed, because we don't have all of the gooey bits and the DNA, and there's still 4 species today and 3 genera. Like, it's not just this one species. But they have been successfully surviving in very similar environments, it seems, all around the world. So it's a good to be a horseshoe crab is really what the stabilomorph idea is promoting.
And that this is identified within the same genus from 150 million years ago to today. Which, I should note, is a thing that makes me a little bit uncomfortable with the stabilomorph definition. If we are saying that this is a genus that has persisted through mass extinction events. Well, genus isn't particularly specifically defined.
That's, yeah.
If your definition relies on
another definition
that also is argued with.
Well, and that's something I was also definitely going to point out is with stabilomorph, that means that when phylogenies get rewritten and taxonomic shifts happen, what was a stabilomorph suddenly can't be, and what might not have been suddenly could be, which is, that's not unusual in science, but it definitely means that you could have shifting happening for not arbitrary, but, seemingly at random as research happens. So the horseshoe crab is one of those where I get it.
Oh, yeah.
Like,
it checks a lot of the boxes.
I don't have a lot of good arguments against why you shouldn't use that term there, except that it's not. It's this species wasn't alive back then.
Right.
And that's really the key for a lot of these is this horseshoe crab wasn't alive back then. That one looks like this one, yes, but it's not. It's different enough to call them different species.
Right.
We still identified it as a separate species.
And that's really the issue with the term living fossil, is it gives out that impression that you're looking at something that also walked with T-Rex.
Yes.
So, well, that's not exactly how it works.
That's not what is happening. The morphology is similar. The morphology has persisted for whatever reason. Another similar category of that are tadpole shrimp or shield shrimp. These are your Notostraca. And this is the things that if any of you have ever gotten those little packets with the eggs you put into the water and they hatch and it does little shrimps that do the backflips as they filter feed. These are those. The common one you'll hear about is Triops, which is in the family Triopsidae. And that's the one that is in the stores and everything.
Yeah.
They have eggs that can survive long times once they've dried out, and as soon as they contact fresh water, they hatch.
Yeah. Is this what sea monkeys are?
Yeah, this is what sea monkeys classically were.
I wasn't sure.
And Triops specifically is usually the example, but tadpole shrimp have been called living fossils because their fossil record doesn't go back as far as the horseshoe crabs. Only 300 million years to the Carboniferous. So it's still ridiculously old.
Yeah.
And today's species are fairly indistinguishable, or at least very recognizable to the Triassic tadpole shrimps going back 260 million years ago. So this constancy, that similar form once again, but genetic analysis has shown that they might not be quite so conservative from that time. There was a study that sequenced genes from 270 tadpole shrimps, all known species today, which there are 11 recognized, as well as sequencing DNA from related groups. And what the study suggested was that there actually are 38 distinct species alive today, and that they have undergone several cycles of evolution and extinction since the time where we were calling them, or the time we were looking to call them living fossils.
Mm-hmm.
So that they actually have, their diversity has diminished and rediversified multiple times.
Right. They've waxed and waned, and today have settled on something that looks a lot like what was in the past.
Exactly. So superficially, they look like the same kind of shrimp.
Right.
But actually, they are the result of a new radiation.
Right. So they haven't actually been stable through that time.
Exactly. There are two genera today, Triops and Lepidurus, which seem to have diverged only 184 million years ago compared to the Triassic. So Jurassic, still old. But the diversification of the species within those two genera seems to have arose 73 million years ago. So like once again, it keeps pushing further up where the groups and the species that we see today originated from. This study was once again making that point that yes, it looks similar, but their evolution's way more complex than that. And these are not Triassic shrimp.
Which is another one of those issues that is commonly levied against living fossil as a term, that you're kind of suggesting that the evolution in this lineage has been very simple.
Yes.
Which can mask complexity like what you're describing.
Exactly. For instance, early on, some Triassic species, 250 million year old Triops, were assigned to the same species as some of the modern ones. Current research suggests that the modern species are no older than about 25 million years old.
Yeah.
So, like, it's very easy to be like, yeah, no, it's the same thing.
Yeah.
No, but it's not.
Give it the same name, and now you are masking this real genetic complexity.
And so the 25 million year, now it's a species, not a genus, but like that's younger than our last mass extinction. So
way younger.
That is getting in much closer to a quote unquote normal evolutionary rate that you would expect. But it's not just inverts. We also get things like fish that fall into this category. Two very common ones. The lamprey, and the hagfish gets this, but the lamprey is typically what you see referenced more often, is jawless fish. It's the one with the leech mouth.
It looks like an eel, kind of.
Yeah, it looks like an eely fish, famous for latching on to fish and sucking their blood. These are by far one of the most primitive, one of the more basal vertebrates alive today, in that it is one of the only two jawless vertebrates, jawless fish left around, the lamprey and the hagfish. It has not evolved fins, nor true teeth, nor limbs of any sort.
It's very basal, it's very ancestral in its features.
Yeah, they also, I think, have cartilaginous skeletons, but I'd have to double check to make sure. I'm pretty sure they don't have calcified skeletons for the most part. Your oldest lampreys go back 360 million years ago going from the Devonian all the way to today, and look very lamprey-like,
right,
which indicates they specialized to their weird lifestyle fairly early on and have continued being lampreys up till today.
Been existing as lampreys while all the other fish were doing wacky, diverse experimentation and evolution.
But with that being said, there are 38 known lamprey species, which is more than I realized.
Interesting.
Only 18 of them are parasitic.
Okay.
So it is not that they've just all been doing the same lamprey thing. There's actually a diversity of lifestyles to today's lamprey. Some are parasitic. They do feed, they predate and feed on the blood of fish. Others are filter feeder as young and don't feed as adults, feeding off of the nutrients they collected as a juvenile.
Huh.
So, like, once again, they've kind of gotten pigeonholed into like, yeah, we know what a lamprey is. I didn't know that there were adult lamprey that didn't eat.
I didn't. And this makes me wonder how often the living fossil term gets applied to a species or a group of animals or plants or whatever, because it's not common knowledge how diverse they actually are.
Exactly. Also, there are only 5 known extinct species. Because their fossil record is not great.
Yeah, so not only are we potentially underestimating the diversity of the living ones, we are also underestimating the diversity of their extinct cousins.
So that's a big complaint a lot of times, is there are lots of organisms on the living fossil list that are called living fossils because we have this one really old fossil that looks like them, but then not much else, either in general or in between that and today's. So it's like, okay, yes, but you're missing a bunch. So you can't say they've been the same.
Right.
Like, for all you know, the whole group got really big and then really small again and happened. Like, there could be this whole weird adventure in between where they look the same. There could have been giant lamprey that swam around like sharks, for all we know, that just didn't fossilize like sharks don't fossilize.
Right.
Because they didn't have true teeth. So, lampreys, I didn't find any research arguing against it, but a lot of things about their situation means it may be premature to call them a living fossil until we know more.
It's hard to assess.
Exactly. Now we get to another one of the big names, the coelacanth.
Hey, I've heard of those.
We already mentioned them as a Lazarus taxon, which they are a pretty, dead shoe-in for Lazarus taxon.
I mean, that is the example of a Lazarus. Mm-hmm. So this idea of a thing we thought was extinct and then found it.
Because this is a group we knew of in fossils before we knew of it living.
Episode 83.
We had lots of fossils of them, and then found the living ones long after knowing them as a fossil group.
Right. And recognized the living ones from the fossil relatives.
So that's where they get their living fossil nomiker, is that they were immediately recognized by someone who knew the fossils. They saw this fish and went, that's a coelacanth.
Yep, I don't know. I've seen fossils.
Yeah, I don't know where you got it from, but it's a coelacanth. How'd you get it alive? So my reanimation machine. Today's coelacanths, once again, you can go back to our episode for more details on this, fall into one genus, Latimeria, and two species for sure, maybe a third. There's a third population that's genetically distinct, but maybe a species, maybe not. And the youngest coelacanth, like confirmed coelacanth fossils, date back to 66 million years ago.
The other side of the mass extinction event.
And then there are fragments that potentially might be coelacanth in between that. But other than that, nothing until we find the living ones.
Right.
Why we assumed they were extinct. Mass extinction and then no more coelacanths.
Yeah. Open and shut case.
Yeah, if it sounds like an extinction and it walks like an extinction. There have also been studies that have indicated they have particularly slow rates of genetic evolution, and they are not showing new forms, new morphological features at the same rates as most other animals.
Right. So they are, like Simpson's term, bradytelic, that
yes.
They are slow evolving. There are changes happening, but not at the same, at as a rate as quickly as other organisms.
One famous study that is often referenced from 2014 compared the evolutionary histories, but the same length of evolutionary history of a perch, a hummingbird, and coelacanths to get another fish and a tetrapod, and found that the coelacanth's evolutionary rate, their average showing of new forms, was half the rate of the other fish and 6 times slower than the hummingbird. So very slow compared to the other test subjects.
Right.
Other researchers have often pointed out that, yeah, but a small specialized bird also makes sense that it would be evolving more quickly.
Right.
So this is not by any means a nail in the coffin, but they looked at 2 other groups. But it did support slower evolution, and they're a less diverse modern group. So, like, we're hitting slower evolution, fossil groups that are identifiable, and rare or less diverse groups today, and also in a geographically isolated compared to how they were.
Right.
So a lot of the points on the list, but it's debated. There are actively papers out there that are calling them living fossils. There's also one that was titled Coelacanths as, quote, almost living fossils, and then another that was why coelacanths are not living fossils.
Yeah.
It is actively being debated. Some research has come out to contradict the stance that their genetic evolution is slower. They show slow substitution rates, meaning new genes are not shown to show up as quickly in them as others. But some research has argued that low substitution rate does not indicate slow evolution.
Right.
It depends on, there are other features that affect it than more so than just substitution rate. So that is not necessarily an indicator, There's also some people who have claimed that studies that don't indicate low substitution rate tend to get ignored or put aside because they're seeming like bad results. And even though they were recognizable from the fossil record, today's members are the only members of their genus.
Right.
There is no fossil evidence for Latimeria. The closest relative is Macropoma, which is a Cretaceous genus of coelacanth, and even it is distinct from today's by a few features, both size and skull shape. So they also make the point of like, yes, you recognized it from the fossil record and recognize it as not only a new species, but brand new genus.
Right. This is a new thing right off the bat.
Like, even with that, you still could tell that it was obviously different.
Now it starts to have that feeling of like, less like, here's a species that has been around forever, and more like, hey, that's an extinct kind of dragonfly like our dragonflies today. Yeah, it's the same kind of thing.
And then they also point out that the Lazarus taxon situation is also not a great argument for the living fossil, because we're missing 65 million years of fossils.
Yeah, I was going to make that same point. We're missing all of the fossil record of our living genus.
Yes, we have no fossils. We have no clue what their fossil record is, because it's all gone. Or at least we've not found any of it.
Right.
This is an ongoing thing. A lot of these papers are fairly recent.
Yeah.
Are still coming out with people saying like, hey, stop calling them that. And people are going, no, I'm going to call them that. And the coelacanth, even as famous as it is, for being a living fossil, is not agreed upon. Now, next I wanted to mention some reptiles that often get grouped into living fossil. Some which have a decent argument for it, like the tuatara.
Mm-hmm.
The tuatara is the only rhynchocephalian left today. That's it. And rhynchocephalians used to be a big deal group of reptiles.
Sure did.
Way back when. And now we've got the tuatara. And they're only found on New Zealand. And that's it. So it is something that goes back there. Rhynchocephalians go back over 200 million years. We have one group.
Yep. The
left.
relic, like you described before.
Yes, definitely a relic in one area. It is reduced area, reduced diversity with a long history, and lots of the fossils are readily recognizable as tuataras. Those are all real good arguments. Except, if you remember when I, in our New Zealand episode, mentioned a bit of research that showed they seem to be evolving faster than everything else. Than all other tetrapods, from the research at least, shows that tuataras actually evolve very quickly. Their genetics, at least, are changing very quickly and readily.
So even though they look like some of their ancient relatives, lots of change is happening.
On the inside, they would be very likely supremely different from even a very recognizable fossil tuatara. So even that, like, oh, of course a tuatara is going to count. Does it, though? And then the other ones that get called living fossils, I will die on this hill. Crocs and turtles.
Yeah.
Are not living fossils.
No. They have had an incredible diversity in the past. Both groups, as we've discussed in episodes 2 and 60, lots of diversity, lots of evolutionary pathways. It's weird to me that people point at turtles and say living fossils, because they're super diverse today.
No, even by the laziest definition of the term. No. Because for a lot of the times, yes, turtles and crocs have been around a very long time, but they're ridiculously diverse. And a lot of the times, especially with the crocs, when you're pointing an example to be like, no, they look the same as the time of the dinosaurs they do today. Okay, what you're pointing at isn't what you think you're pointing at. Dinosuchus is more closely related to an alligator than a crocodile. So whenever you guys decide to put a picture of Dinosuchus next to a Nile croc, you're wrong.
And Sarcosuchus isn't even in the crocodilian...
No, it's not a true crocodile.
Yeah.
It is closely related, but not a true crocodile. And this ignores the fact that croc-shaped things have been around for forever.
Right. That shape is a good shape.
Yes.
But like even the earliest tetrapods, we discussed in episode 77, some of the earliest fish that moved onto land had the croc shape.
And there are like stem amphibians that have long, like skinny gharial snouts.
Mm-hmm.
Like that have croc snouts.
And phytosaurs had the same skull diversity as modern crocodilians do.
And armor.
And armor. Oh, no, they had all the stuff.
Like,
they even had a palette, a
yes.
version of a secondary palette. This is like episode 73, we talked about trees.
Yes.
Right? Multiple groups of plants have come up with trees because it's a good strategy, but that's not the same thing you're comparing if you're comparing a carboniferous tree to a tree today.
And so it's also, this is where we get into the vagueness of the term of what do you mean morphologically similar? Because today, people can't tell apart an alligator and a crocodile. I can tell you whether it's a Cuban crocodile because I know what to look for. So, like, what do you mean similar? Yeah. Is it the fact that they're in the water and they have teeth?
Similar according to who?
Yes. And that's... So, some of the most commonly used groups are often very superficially called living fossils. And many of the articles I found blamed for crocs and turtles just because they, quote-unquote, look old.
Yeah, and they do.
They
for whatever reason,
yeah.
we point at those and they go, that looks ancient.
It's like if you ask someone to take, like if I ask you to take, Bowser from Mario, but make a prehistoric version, you're going to add features that crocs and turtles have.
Yep.
All right, we'll give them more armor and craggier and more prominent teeth. Oh yeah, you're giving them features that we have decided in our zeitgeist is prehistoric.
Right. Probably because of the way that paleo artists and movie makers portray ancient things.
Maybe because our portrayal of dinosaurs was based off of crocs a lot of the time. But it's not just our scaly and boneless friends, and sometimes scaly yet kind of boned friends. It's also mammals. There are mammals that get called living fossils. Less often, though.
Yeah, they don't look ancient.
They don't look ancient. But there are some that get called it for weird reasons. The platypus is one where the platypus fossil record, like, monotremes definitely are an old group. But, like, I've never heard claims that it's like, yeah, platypuses just go way back to the beginning of mammals. But they look very...
They look like they don't belong today.
They look transitional.
Right.
Like, it looks like they're getting ready to be a real mammal. And that they are between worlds. And then you also get stuff like the opossum. The American opossum gets grouped in sometimes because it has similar features to early marsupials.
Right.
A lot of its characteristics, it's the teeth it has and some of the morphology are very reminiscent of early marsupials, even though they're a very recent group, actually. Mm-hmm. Like, they're fairly modern in their evolution.
They just have retained a lot of ancestral features.
Or maybe re-evolved
similar
ones.
That are readily recognizable at first glance.
And once again, they look weird, quote-unquote.
They look weird.
So we like to, it's much more easy to go like, yeah, sure, that thing shouldn't be here. So you do get it with mammals, but it's a lot less common. A lot of times, reptiles, fish, and inverts get it. But plants get it as well. There are a few plants that often get grouped with more ancient plants, either because they were more common in ancient times, or there are times that are famous for those plants. But there are a few where their fossil record is persistent all the way up till today. Probably the most famous of these is the ginkgo. The ginkgo tree, the maidenhair tree, it's got also a lot of other names. Ginkgo biloba. And I'm sure a bunch of you went, oh, I have something with that in it. Ginkgo biloba is a gymnosperm tree that is the only species of its group left today.
Of a big group.
Of a big group.
Not like the only species of its genus. This is a big ancient group.
And the fossil record goes back almost 300 million years. And many of those fossils have been described by experts as basically identical to today's ginkgo. So, like, ginkgo's been a ginkgo for a long time, it seems. It's also extremely taxonomically reduced. One species. And though it's very widespread nowadays, there are people who think it might be functionally extinct in the wild. So, originally it was Chinese. It's from China. But the groves that have been pointed at to be remaining wild populations have also been suggested that they've been tended to for hundreds of years by monks. So that they were actually human orchards. So they may not be geographically reduced now because we've decided we like them. So they were on my college campus. We've put them everywhere, but like they are potentially functionally extinct in the wild. So I don't know where that falls on the graph of your geographic diversity, but it's weird. So it's not a bad candidate for living fossil. It's definitely one of the most common. It's the most common with plants that I ever see. But there is some research that might give it a little more diversity than we would have typically thought. For a while, there was a gap of about 100 million years from today's ginkgo to the most recent fossils. So we didn't have the recent evolution. A fossil discovered in 2003 from the lower Cretaceous fell within that gap. So it filled in some of that. It was from China, like you'd expect. And it did show that the reproductive structures, because ginkgo's weird in the fact that it has male and female trees, which it's still always super bizarre and alien to me. But the reproductive structures of ginkgo were more like the present day than they were like the Jurassic. Okay. So there was still evolution happening during that time. You know, they weren't just, Cretaceous and boom, but it still was definitely ginkgo. It's still very similar.
And if you're going to see evolution happening anywhere, reproductive structures are typically a good bet. Yes. Those tend to be, those can be under very strong selection, as we've discussed.
So, and I think I said that it was a 100 million year gap to today. There was a 100 million year gap in the record. This one brought it up to 100 million till today, like fell within that. So now we can say that morphologically, it's more or less been the same for the last 100 million years. So ginkgo is a pretty good candidate. The cycad is your other plant that often makes the list. So cycad trees are famous because their fossil record goes back almost 300 million years again, 280. So their heyday of diversity was the Jurassic to Cretaceous. So they're like the dinosaur trees, the dinosaur plants that you always see in all the art and everything.
Yeah, they're like the Tuatara.
Yes.
Hit it real big in the Mesozoic.
So big deal. Today there are just 300 species. So it's not like they're
just a few,
dwindling down to extinction, but that is still considered greatly reduced from what their diversity was. So they were big deal. Now less so. And have looked like cycads, been recognizable as cycads, called living fossils because of that. More recent studies, though, have looked at the evolutionary history using molecular phylogeny, so looking at the genetics, and found that today's population is actually the result of a re-diversification in the Miocene. Fairly recent.
So similar to what you described with the triops.
Exactly. The diversity we have today does not seem to be what's left over from the Mesozoic, but is a new bloom of cycads.
So to speak.
Yeah, exactly. So the species we don't know today seem to be, at most, just about 12 million years old.
Okay. So again, a new diversification that is similar to the ancient ones.
Yeah, because being a cycad evidently is pretty sweet. So as they put it, it's less of a descendant situation, much more of a comeback.
Yeah.
What we have today is a resurgence. Now at this point, we're reaching the end of our episode. There are tons more examples we could give, but I wanted to wrap things up by giving us individually a moment to kind of give a few thoughts on the term. And we'd love to hear your all thoughts in response to ours. Like, if you have opinions on this, please share them.
Yeah, what do you think of the term?
Because this is a complicated term. And so if you would like to fire off, if you have anything to say about living fossils, I'll hand it over to you.
No, me, I don't like it.
No, I don't either.
I don't like the term because all the reasons that when we were complaining earlier.
Mm-hmm.
I definitely appreciate the efforts to sort of bring some legitimacy to it and sort of give some more technical definitions. These are the qualities, these are the things we're looking for. I like that somebody went ahead and came up with stabilimorph to describe a term for organisms that follow a certain evolutionary trajectory. And And I understand that some people like it as a, some people like catchy tools for getting people's attention and teaching with it. I tend to fall on the side that I think that it's far more misleading than would justify other arguments for using it. And honestly, I don't even like Stabilomorph very much certainly not as a replacement. And I can't help but feel that the efforts, the definitions that you listed, that you went through, even with the more scientific, the more technically minded approaches, I feel like we don't need that.
Yeah.
Living fossil feels like a term. Living fossil and then proposed replacements, they don't feel necessary because what we're describing is, as we've seen here, a very complex, very diverse set of circumstances. A lot of the animals and plants we talked about have very unique situations, especially as we learn more about them. It feels Stabilomorph and such feel, funnily enough, like very unstable terms.
Yes. No, I'd agree. I understand the want to bring note, bring notice and bring attention to organisms that show some of these weird trends. They're weird. Like, yeah, the coelacanth situation's a weird situation. We should pay attention to it. But I don't know that anyone wasn't paying attention to it. I don't know that we would have been ignoring it without calling it a living fossil.
Right.
The other reason it bugs me a little bit is living fossil sounds like a categorization, even though it's not, but it sounds like one. And that should usually include that there's similarity between the members of that category. And there's not really. Like, the time frames are vastly different. The diversities are vastly... Like, there's 300 species of cycad, and that counts as living fossil? Like, really? 300 species? That's a lot. So it's like, there's so many different reasons, or so many different kinds of organisms that get included in that it just feels like they're getting thrown together. But if you gave me all these animals as a group, all right, and what does this tell me about them? Like, because I can't draw a single conclusion about the group in any way.
Well, and I think that, of course, the next question is, all right, what do we do about it?
Mm-hmm.
And I think a lot of people like this term.
Yes. People
who've grown up with this term. And, there is some merit to, if a catchy, misleading term got your interest, cool, I'm not going to bash that.
Yep.
And so I definitely don't condone walking around correcting everyone who says living fossil.
Well, and that's not going to work.
That's not productive. And it's mean.
And no one's going to... All you're going to do is have people who go, well, I'm going to use it more now.
But I would suggest, from my own opinions and perspective, that we just stop using it.
That's my position on it as well. Is there's no reason that we need to try to kill it, because that doesn't work. That's not how education works, and psychologically, that's not how humans work. So you won't do it. We can write as many articles as we want explaining why it's bad. That's not going to get rid of it. If we just stop using it, but are ready to discuss it when it comes up,
mm-hmm.
then and when it comes up, I would tell people all the time, it's like, oh yeah, that term's not always great because it means a lot of different things, but here's why they get called that, and here's why it's not a great fit.
Right.
And then I move on. I don't squash them. I don't kill their enthusiasm, but I'm not going to use it again in conversation.
So I think, I fall on the side of, I don't like the term. I'm not going to use it. But there's as much diversity of opinions as there are creatures that are called living fossils. So yeah, if any of our listeners out there have strong opinions.
Oh yes, because we are both coming from an educator mindset where it is probably the worst category for the term of the general public. This is where people are most likely to misunderstand it and most likely to either accidentally or purposely misuse it. So like we're both coming from a position of not great experiences and opinions of it, but we'd love to hear if you have similar or differing ones.
Sure. Go to places like Facebook and Twitter or Patreon where discussions can happen,
and we'll be happy to hear them and respond. Before we sign off, we do have a patron question.
Oh boy.
So those patrons that we shout out and levels above also can ask us questions that we'll answer here on the podcast. And our question today comes from Lydia. Lydia asks, if the KT extinction didn't happen, how might non-avian dinosaurs have evolved with the rise of grass and grasslands?
A interesting speculative question.
Yes.
Well, we talked in episode 38 about how grasslands impacted the evolution of mammals, and how you saw the rise and diversification of groups that were grazers and groups that you had a lot of the familiar shapes these days of horses and gazelles and savanna, grassland, plains dwelling things.
The familiar hoofy animals.
So I would imagine that I definitely think we would see a lot of change in the herbivores.
Absolutely.
Because there weren't really dinosaurs adapted to eating grass, because grass wasn't enough of a thing back then for that to be anyone's specialty. So we would see grazing adaptations in dinosaurs the way that we see them in mammals today. And we talked in the teeth episode 88, about how a lot of mammals have changed their tooth structure to fit with eating grass, which is really, really tough to eat.
Yep. And I would assume that a lot of the herbivores, because we talked about it with the ceratopsians, that they have crazy sets of teeth for grinding stuff up, and hadrosaurs are famous for being able to chew up whatever they want, that they probably would adjust fairly quickly and easily.
Oh yeah, those groups I assume would... hadrosaurs would almost certainly have still been around.
Mm-hmm. And I would suspect that ceratopsians would do equally as well. I do wonder about beaks. If beaks would have continued to be as prominent as they were.
Interesting. I mean, we have a lot of beaks still today.
We do, but
in birds. So maybe specialists in certain things.
But like in those birds that do graze, which that's not the common. You know, there are grazing birds, but they also have, you know, wider, flatter beaks a lot of the time. I'm wondering if we would start seeing more cow, and I can't remember which rhino it is, that has the flat snouts for getting down to the edge, the bottom of the grass, or if their beaks would stop being parrot-shaped.
Yeah, it's interesting. I would also wonder if certain groups would do better. So like ankylosaurs, which are already very low to the ground.
Yep.
Would they have been able to adjust to this new feeding style? I also wonder if it would affect social structures. So today, we're at the places we see vast herds tend to be out in plains, out on the tundra, out in the savannah.
Exactly.
And I wonder what it would have done to predators.
Yeah, I was thinking about
we
predators.
See faster, you know, long distance runners, faster things, because if you're out in the grasslands, there's more space to run around. There's herbivores finding food in a more variety of places.
Yeah. Well, my general bet is that most dinosaurs would probably adjust. I'm sure there's ones that wouldn't, but like most would probably adjust. And like thinking of predators and stuff, I mean, most of the ones I can think of, I don't see why they wouldn't be able to do well. We would probably just see little specific things of like, I now need a flat face because I need to reach all the way down to the ground instead of nipping.
Right.
I'm not nipping branches. I need to get down to the roots. And now we need to run for long periods to chase down prey. But, you know, it's kind of like how the Ethiopian wolf and the timber wolf are different, but I mean, they're both wolves.
Yeah.
You know.
The other thing that I think is interesting to think about is that the spread of grasslands was associated with cooling climates.
That's a very good point.
That's probably... That would probably be another major factor on who does okay in these particular... with this shift.
Things like sauropods and the bigger, more extreme kind of groups and individuals fare as well.
Yeah.
That's a very good point.
So if they had survived, I mean, they would have had to go through the Paleocene-Eocene thermal maximum, through the cooling times. And so I do wonder if sauropods would do okay eating off the ground.
I don't know.
It's a lot of body to feed.
I feel like what would make sense to me with them is smaller sauropods.
Yeah.
Like, start becoming small, have a herd.
Or they're restricted, because that's the other thing that would happen is that, and we see this throughout mammalian history, animals that are real good in the forest lose out habitat because grasslands took over for forests in a lot of places.
And they don't necessarily disappear, but they stop showing up as many places.
Right. And so you would have groups of dinosaurs dwindling because, not because they couldn't handle living in the grassland, but because they were good at the forest enough to stay there, and you're going to lose forest.
Yeah, you're going to have the monster in the trees, this T-Rex remains ambushing things from the tree line.
It's a fun thought experiment.
Yeah. Yeah. Ooh, I bet they'd become, feathers would become more prominent if they were indeed temperature regulation.
Yeah, it could be.
So we might get woolly dinosaurs.
Ooh, yeah. I'm on board for that.
Right? Good question, Lydia.
Thanks.
And with that, we bring our episode to a close. The end of episode 90. Thank you all for listening. I hope you enjoyed our discussion of this interesting, if highly debated term. If you have questions or statements or more you'd like to hear from us, let us know. Share your thoughts on our social medias, our blog, our email, the comments section of YouTube. Put a review on iTunes. We'll love to hear it. Thanks once again to our requesters for suggesting we do this. This was a fun episode.
Check out our Zazzle store for merch. Check the description of this episode if you want to look through the resources we've put up there in regards to racism in society and in science and education, and for links to the Zazzle store and for the link to the blog, which there's always a blog post with each episode.
Check out the blog and see a bunch of links having to do with this. And otherwise, we release fortnightly, so we'll see you in 2 weeks.
For episode 91.
91.
See you then.
Bye, everybody.
Thanks for listening to the Common Descent podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.